What is mono? What is that? 1. Okay, so monomials, remember, we couldn't have any adding or subtracting because that would be either a binomial or trinomial, and that kind of thing, which is what we're going to talk about now today. So polynomials, poly means many, and again, nomial means number, so we're literally saying many numbers. So polynomial is a monomial. A monomial is part of polynomials, or we can have a sum of monomials. So a binomial is a sum of 2 monomials. I always think of it like a bicycle. A bi means 2, like it has 2 wheels. So we're saying 2 numbers. So 2 terms are separated either by addition or subtraction. So trinomial, like the tricycle, has how many wheels? 3. So it's a sum of 3 monomials, again separated by addition or subtraction. If it's 4, you just say it's a 4-term polynomial. There is no special name for anything of 3.
Are you going to do anything about 3 today?
I don't believe so. So we just answered our question right there. Polynomials with more than 3 terms have special names. If you combine any like terms before you classify a polynomial. And remember, polynomials without variables in the denominator or negative exponents. Okay, so we get some examples. We've talked about monomials already, so they can be just a constant number, they can be a product of a variable and a number. We can have different exponents in there and multiply as many things together as we want to, as long as there's no adding or subtracting. But with binomials, notice we have adding and subtracting, and we're adding or subtracting 2 things. So it's a binomial, trinomial, we have adding and subtracting, and we're adding and subtracting 3 pieces. Makes sense, right? That's what you're supposed to do. And example 1 says, take whether each expression is a polynomial if it is identified as a monomial, binomial, or trinomial. So what do you think? Is this a polynomial?
Yes.
Yeah, because there's no variables in the denominator, no negative exponents. What do we classify it as? Binomial. Okay, B. Is that? No? Why not?
Because the negative exponent.
C.
Yes.
Okay, what would we classify it as? And D. Yes.
4-part polynomial.
Are you sure? Yeah. Always look and see if we can combine like terms first. So this would be the same as 4a squared plus 6a plus 9, right? So it's really a trinomial in disguise. Okay, example 2 asks us to write a polynomial to represent the area of the shaded region. When you come across things like that, notice that it's like they took a circle out of it. Okay, it's like they cut a circle out of this rectangle. So what we're going to want to do is find the area of the rectangle, and then we're going to subtract the area of the circle. Okay? Okay, so how do we find the area if this was a whole rectangle?
Base times height.
Base times height. What's the base? B. They don't actually give us a number, it's just B. Okay, so base times what's the height?
2r.
Ooh, 2r. Yes, because here is r. That goes halfway. Because I know I can draw another r going up. Right? So 2r.
And it's minus pi r squared.
Can we do any simplifying? Is there anything that we can put together? Anything? Nope, so that's it. And we can say units squared. Since they don't actually give us any numbers to plug in, we can't figure out exactly what the area is, but we can write an expression. Any questions on that one? It's probably one of the harder ones that we'll do today. Everything else is pretty easy. Okay, a degree. Degree of a monomial is the sum of the exponents of all of its variables. And the degree of a polynomial is the greatest degree of any term in the polynomial. To find the degree of a polynomial, you must find the degree of each term. So in other words, if I was looking at this one, first, or if we're going to classify it, is it a monomial, binomial? It's a monomial. Okay, so we're going to look at all of the exponents on the variables. Okay, so what are my variables? 1. Okay, m and n, so our exponents are, 1 and 2, and understood 1. So if I add 1 and 2, we get 3. So the degree is 3. That's it. Degree is 3. Okay, if I was looking at the next one, if I was going to classify it, what is it? Trinomials. We have 3 parts. So we're going to have to find the degree of each term and then figure out which one is the biggest. Okay, so if I was looking at this first term, remember they're separated by the addition or subtraction signs. What's the degree of this first term? 4. This 2 plus 2 is 4. What's the degree of this second term? 2. And what's the degree of this last one? What is it? 0. There's no variables at all. Which one is biggest? Degree is.
Can you just put 4 and then the little circle to represent what there is?
No, because we're not actually talking about an angle. Okay, C. Again, we're going to find the degree of each piece, right? So 1, what's the degree of this one? 2 degrees. 3 and 0. So the biggest one is 3. Yep. Yeah. Okay. The terms of polynomial are usually arranged in a certain way to make it easier to check answers, because if everybody put it in a different order, it makes it harder to check answers. So usually what we do is we arrange them so the powers of one variable, usually an x, are in ascending. What does ascending mean? A to Z, so I'm starting at the beginning or the end. Ascending means I'm going to get higher, right? So low to high. Or you could say increasing. It's probably what the mathematical term. I was thinking of ascending, like A is the beginning, so I'm going to go higher. Descending, like, goes down. Descending down. That's how I think about it. So descending, that's the other way. Goes to decreasing. So high to low. Okay. So, in example 4, it says arrange the terms of each polynomial so the powers of x are in ascending order. So are we going to start at the high or the low? Low. Starting at the low. Okay. So what I would do first is I would figure out the powers of each term. Okay. What is the? Well, you don't have to really do that. I would just look at it and see. Okay. Here's an x. Here's an x. Here's no x. Okay. So if I'm starting with the low, what is the lowest? -1. Right, because in this case we have like an x to the 0. There is no x. So that's what we would start with. Then what's the next highest? 2. Right, so we're just looking at exponents. Our next highest exponent on the x is 2. And then we're left with 2 or x to the 4. And that's all you do. Just going to arrange it in order. Okay, on B before the y's, don't let those confuse you. All we're looking for is the x. That's all we're worried about. Okay. Okay, so which one has the lowest x?
No, the y squared.
The y squared, because there is an x. It's like an x with a 0. Okay, what's the next highest x?
2 times x times y.
Good. And I like to go through and cross off. There's a lot of them just so I know they've written them down. Okay, we'll go next size x.
Minus 3x squared.
Good. And why don't you use a minus? Because yes, the minus or the negative has to come with it. So then we're left with 5x to the third. Alright, last one. It says to arrange the terms of each polynomial so the powers of x are in descending order. So we're going to start high or we're going to start low? We start high. Okay? What is the biggest exponent on the x? It was So start with negative 2x to the third. And what?
Minus 8x, no, plus 6x squared.
Yeah, we want the 6x squared because we want the next highest exponent.
Then minus 8x and then plus.
Good. And B again, so what those 8's confuse you. What we're looking for is the x's. What's the highest x?
4x.
Good. And what?
3 to the third times x. Maybe 9k squared. That's minus 8.
Any questions on these?
So we're not like solving, we're just like figuring.
With polynomials, there's usually no solving. Usually we're just simplifying, or at least in the stuff that they're reading in this chapter anyway. We're just usually simplifying and rearranging. So your homework is to look